Hi everyone, so far we've been focusing on resistance, and there's only so far you can go with just resistance in an electric circuit. You can power a flashlight, and that's about it. So we want to take this one step further, and in this video we want to combine resistors with capacitors. This is called an RC circuit as a consequence. And so basically the simplest possible configuration would be a voltage source here, and you combine it with a resistor and a capacitor in series. So what happens in that case? Well, initially, if we imagine the capacitor is not charged, then nothing happens. Okay? And so once we attach the voltage source here, this voltage source will push current through the resistor. It pushes through the resistor according to Ohm's law, and so we get a certain amount of current associated with this voltage. Now what happens is the charge hits the capacitor. The capacitor has an insulator in the middle and will block the flow of charge and basically start to collect that charge. And not only will it collect the charge, but that collection of charge induces a certain amount of voltage to sit inside the capacitor. Now notice that if I've got a voltage source here which is at a constant level, and I have a voltage source here that's growing, the net voltage across the resistor is decreasing. This is absorbing, effectively, some of the voltage, the power, the electromotive force here, and basically I have a reduction in current as a consequence because the net voltage difference across the resistor is a little bit less because there's now some voltage being dropped across the capacitor. And so as a consequence, the current starts to slow down, which means the capacitor starts to charge up at a slower rate, and eventually things stabilize until the total amount of voltage that's in the battery is sitting across the charge. Then the capacitor is fully charged because this voltage drop here equals the voltage drop on the battery. There's none across the resistor. No voltage, no current. The thing stops. And now the capacitor is fully charged. And that is what this picture here is designed to represent. This is the total charge on the battery. Over time, the voltage across the capacitor increases until it meets the voltage on the battery. The voltage drop across the resistor drops over time, and this is an exponential curve. And the current flow is related to the voltage here through Ohm's law. And so this exponential decrease with time is what these curves represent. And so this is the fundamental formula for current flow in an RC circuit. And also that's related to the amount of charge on the capacitor through the definition of capacitance. So combining these formulas, you get what's on the board. Now, one interesting thing here is that this denominator here, the RC, is actually a unit of time, because otherwise the units wouldn't balance here. So our resistance times capacitance, ohms times farads, are seconds. And that is called the time constant associated with the RC circuit. Basically, the product of the two, product of the R and the C, is the time constant. And that is what controls how fast these curves go up and down. So, essentially, if you put in the number 3, -3, that quantity is going to be about 95%. In other words, the e to the -5 power is about 0.05. And so what that means is that essentially the capacitor is charged up to about 95% of the level it's going to be. Effectively, it's charged. After 5 cycles, after 5 time constants, it's at 99% of what it's going to be. And so that's essentially how we use the time constant. It gives us a gauge on when we know the charge has completed the capacitor has been completely charged. Now, suppose I have a fully charged capacitor. Imagine this battery's not here. Suppose I have a fully charged capacitor and a resistor, and I just drop a wire, I short the circuit. What happens? Well, the capacitor will discharge. Current will flow through. Basically, the capacitor then acts as the battery and will flow through the resistor, but it's a really bad battery because every time charge leaves, the voltage will drop. And so again, you kind of have in reverse another exponential decay associated with the discharging of the capacitor.